under the SDG programs and organizes its work on the exchange of information, promotion, and commercialization of advanced technologies with the involvement of leading experts in various sectors of the economy. In our case today, with special attention on energy sector. Our topic today is transformation leadership with renewable and decarbonized gases. What I would like to say about today's topic, in the context of the trend of rising prices for natural gas, structural crisis in this industry and political risks, the EU countries are forced to increase the transformation of such promising energy resources as renewable decarbonized gases in order to cover part of the deficit in natural gas. The introduction of new gases minimizing the greenhouse effect contributes to the concepts of the SDGs. SDG 7, affordable and clean energy, SDG 3, good health and well-being, SDG 9, industry innovation and infrastructure, SDG 11, sustainable cities and communities, SDGs 13, climate action. The future for the replacement of hydrocarbons is considered for biogas, hydrogen, a mixture of gases, and synthetic gases. The recommendations for the development of the gas sector of the Committee of Sustainable Energy focus on such problems as taking into account the variable nature of the demand for natural gas, expanding the concept of renewable energy to include the terms renewable, decarbonized, low carbon gases, support of the hydrogen market, determination of the principles of transportation of new gases, clarification of the rules for access to gas distribution networks, gas quality management, introduction of standardized systems of guarantees of the origin of new gases in the entire European market, ensuring the sustainability to power to X technologies and technological innovations. We have invited today very distinguished speakers. We will introduce them, our colleagues, just a little bit later. We have invited my colleague from Italy, from UTEC, Director for IoT Alliance, Mr. Alessandro Iacoponi. I would like to ask Alessandro to make a short presentation about UTEC, about our chamber, and I would underline that the main goal of our chamber is giving new business possibilities to our members, giving commercialization of all the projects. Thank you very much for your attention. And now, Alessandro, we are waiting for your presentation. Thank you.
Thank you, Igor. I hope you can hear me well. Thank you for your very nice introduction of your digital events of today. And good morning, everybody. We are all guests today of the Energy Alliance. And I would like to share with you a very short introduction of the European Technology Chamber, who we are, what we do, and our values, and so on. So I hope that you all can take interest in what we do. So the European Technology Chamber is an NGO. We are a no-profit organization where we have a legal entity in Switzerland, and we have some operating offices in Germany, Munich, but we are really a technology organization and globally organized. We are everywhere in Europe and, of course, in the rest of the world. We cover many areas. What technology obliges means? I mean, technology obliges, it's our trademark. It's our trademark that in the years it became a trademark. And with great technology comes great responsibilities. You can find that on our website as a first thing. And because we live in a globalized world and where technology is at the base of pretty much everything we do. And for us as technology companies, we share this view. Yeah, we take with us great responsibilities. I hope you can see my slides. If you don't, there is a little button on the bottom right-hand side where you can restore the presentation, in case you don't see it. We have three main missions. I mean, all based on the same vision that I told you before. This technology obliges. The first mission we have is sustainability. Of course, we go to the 17 United Nations Sustainable Development Goals, our goals for 2030. And the key fact is the fact that we need to leverage technology. We need to develop innovation. And that's why do we need it? We need it because in order to reach those goals for 2030, we definitely need these things. Yeah, otherwise it'd be difficult. The second goal or the second mission we have is grow. So we provide to our members the possibility to access European and emerging markets. Yeah, so we give several tools to our members to grow in visibility, to have networking opportunities, and so on. And the third value that we have, the third mission, is competitiveness, to support European values, European technologies in a global position. How are we organized? We are organized in alliances. As today I told you, we are all guests of the Energy Alliance. I am the director of the IoT Alliance, and so on. But we have many different alliances which are focusing on different topics. We have horizontal alliances for the whole perimeter of the UTEC. For example, such as the regional and the impact alliances. Regionals are focusing on Africa, on China, on Latin America, and Germany. What that means, it means that you, as a member of the European Technology Chamber, are you interested in those regions? You will find inside our organization people able to support you. Yeah, or if let's say you are an African technology company, you would like to find European partners to develop technology in Africa, then you can use our networking in order to find that. The impact alliances, we have academy, we have SDGs, we have finance, policy, for many different topics. I mean, the policy is connected to the European Union and to promote our technologies towards the key decision maker of the European Union, climate action, for those that are interested in sustainable business models. CO2 carbon compensation programs, and so on. Finance for those that would like to meet and find opportunity investments, for example, and so on. So it's plenty of impact alliances that can support your needs. And then finally, the tech alliance, technology alliances. As we said, we are all guests of the energy, but also we have mobility, IoT, digital transformation, which are vertically focusing on the specific technology. So if you're interested in energy, of course, that's this alliance can support you. Or Internet of Things, or digital transformation. We have regular working group meetings, which you can join. You can discuss your point, you can do your networking activities, you can promote your ideas, and so on. So there's plenty of activities you can do in every different alliance based on your interest. You can actually join more than one alliance if you're interested in energy and Africa, for example, and so on. Then moving on, as I said, we have a set of toolboxes, websites that will be able to support you in your networking activities, in promoting you, and so on. So it's plenty of tools you'll be able to do. We don't only do online, we also do offline, such as regular physical meetings around Europe. Then, I mean, because of COVID, we had to stop that. But we have these physical meetings 4 times per year in different towns in Europe, such as Rome, Geneva, Brussels, and so on. So it's plenty of places where we actually meet all together and do our networking activities. Also, we have online with every day we have digital events such as this one, because every alliance do their own digital events every month. So we have many alliances, so it means every event every day that where you can actually participate as speakers, attendees, and so on. Networking tools, as I said already, plenty of possibilities for you to do networking, to meet new partners, to find new customers, to talk about your company, about yourself, and so on. So it's networking meetings. You can join networking meetings every week. Every alliance has its own networking meeting. They are all well published, very easy to join, because we just need to go to the relative website and sign up for the networking meeting of the alliance of your interest, and then you can participate, and then you can introduce yourself, you can talk about your interest, and anything. Of course, we have all our comments from our socials, mainly LinkedIn. You can join our groups in LinkedIn. We publish all our events over there, and so on. And these are, you can find all our addresses, to join us. And I hope that I can see you in our chamber very soon. Anything you need, just write to us, write to Igor, and we'll be more than happy to talk to you for anything you need. So I think, Igor, I have finished my quick presentation, and I wish you a very nice event and good continuation.
Alessandro, thank you very much for your impactful presentation. We hope we will have a very good and very, very productive discussion today. Thank you very much, Alessandro. I would like briefly, yes, you leave us, Alessandro, now, yes, or you will stay?
I will leave you. I will leave you,
okay.
And I wish you a very nice event. Good luck.
Thank you very much. Good luck, Alessandro. So I would like to introduce our today's speakers, Mr. Thomas Schied, business unit executive with more than 20 years of multinational corporate experience in energy and infrastructure industry, with proven track record in driving new business areas, focusing on innovation, sustainability, revitalizing, and team building. Mr. Dirk Bonze, who acts as head of the Department Sustainable Gases at the Berlin office of German Biogas Association. This unit focuses on biomethane, biogenic hydrogen, and other product gases such as CO2 for use of the electricity, fuel, and heat sectors. The consulting of biogas plant operators and companies, the development of concepts for improvement of the political and regulatory framework for the use of renewable gases are among the main tasks of this department and of German Biogas Association. I would introduce also Mr. Thomas Damani, who is founder and CEO of Carbon Neutral Initiative from Jamaica. Thomas is member of UTEC, active member of UTEC, active member of our webinars. We are very glad to see him now here. And also Mr. Georgi Peev from Interconsult Bulgaria Ltd. Currently, he is acting for this company, responsible for the development of the foreign markets, focusing on the financial and defense sector. and previously senior advisor, Greco, GLT insurance brokers and consultants acting on the fields of acquisition and maintenance of new customers and research in the building, energy, and financial sectors. And I know that Georgi also worked with and for very big companies like Biogas, Lukoil, Solvay, Sodi, Akropolchem, General Electric also. But maybe Georgi and all our distinguished speakers could introduce yourself just in a few words after that. But now we are inviting Mr. Thomas Schied, and I will share my screen now for the presentation of Mr. Thomas Schied. Just a moment, it's working good. Yes, you see it now, yes?
Yes.
Okay, Thomas, maybe you can tell us several words about yourself, and then we are looking for your presentation. Thank you. Thomas. Thomas. No, it doesn't work. Thomas Schied is gesperrt. Weiß ich warum. Just a moment. It's a little technical problem, I think, but I have written to our administrator, and now we will cope with this problem. Thomas? No, then, Dirk, maybe we change for your presentation, Dirk.
Of course, a pleasure. So I hope you can see and hear me.
Yes, then just a moment.
But unfortunately, I lost the button to share my presentation.
And now?
No. Let me check. No. Before we started, I had the button to share the presentation, but apparently it's vanished now.
Okay. Yeah. Then I will show your presentation.
Just a second. Maybe I can. I just switched myself to presenter, and this seems to work. Just a second.
Mm-hmm.
So my screen is loading now, it says. But obviously it's taking some time. Yeah, meanwhile, I can maybe start to introduce myself. So thank you, Igor, for having me again. After the introduction of last week, where I learned a lot about the UTEC. So I am Dirk Bonse. I'm the head of Department for Renewable Gases here at the German Biogas Association. And unfortunately, it still says your screen share is loading, so I don't know what is happening here. But yeah, anyway, so the German Biogas Association represents some 4,700 members, which are plant operators, manufacturers, research institutes, public authorities, consultants, and also dedicated individuals, and possibly also you. And we are very well connected. So we are a member of the European Biogas Association, of the World Bioenergy Association. And we have 2 locations. So I am talking to you at the moment from our Berlin head office, the SPEAR head office, because we have here the connection to the politics and politicians, which we, of course, have to infuse with the goals of why and how biomethane is important. By the way, it still says your screen is loading, but nothing is happening. So I don't know what is going on here. Maybe I just try it again. Now I'm sharing my screen. So possibly, yes, now you can see my screen. Very good. Okay, let me switch to presenter mode. So yeah, here, by the way, you see a picture of the Europe campus where we are located here in Berlin. And here in the middle, it's the house of the associations, let's say. So we are here with several renewable energy associations. We are very strongly collaborating because obviously renewable energies has many faces and many possibilities, from solar, from wind, and of course to biomass. Yeah, this was where I talking to you what we are doing. So 40 plus employees and more than 4,650 members. We are actually growing, so it's 4,700 now. And what we do at the German Biogas Association is mainly the goal is to establish biogas as an important component for climate protection. And we are also busy with the definition of legal frameworks and guidelines. So we are also consult the governments, basically, how to build the political and regulatory framework. Of course, information exchange and knowledge transfer is important for us, and we are basically advocating on EU, national, and regional levels. And as you can see on the map, regionality is definitely what also biogas actually does, because as you can see here, we have a lot of regional groups. And biogas is a regional business from my perspective, or from the perspective also of the Biogas Association. As you utilize wastes and residues near you, around you, and then, of course, you have to deal with regional approvals and things like that. So regionality is very important to us. We have several departments, starting from energy, law, distribution, trade and licensing, member services, of course, international affairs. So we have a dedicated international department. We care about agriculture, manufacturers and technologies, which is maybe today the main topic. And we also provide trainings, and we care about waste and fertilizer and hygiene and permitting procedures, and finally policy advocating. So what can we actually do with biogas? And as we are here in a technology forum, I will show you here, actually the circle or the opportunities where technologies are needed. So in the center, of course, we have an anaerobic digester. We have the input material of many residues, and for us it's also important that there is no conflict, for example, with eatable items. So we do not need maize or things like that. We can use waste of crops, we can use the manure and things like that. And then we have the raw biogas. After gas conditioning, we can apply it on a CHP unit. We can produce bio and CN LNG from it, which is my specialty here. And we can, of course, also use heat. We have the digest states, which we can turn into fertilizer, and then actually the loop closes again. So we have the fertilizer, which then also goes into the crops again. Speaking of biomethane, why it's so important from the European perspective, of course, it's important that we have to become independent from Russian gas. And of course, biogas or biomethane is the key, because biomethane is practically identical with natural gas. And so the European Union also formulated a goal that 35 billion cubic meters of biomethane needs to be available by 2030. This is quite an abstract figure, of course, but this means, for example, this European-wide, this can already be covered by 4,000 smaller anaerobic digestion plants, or by 1,000 large-scale anaerobic digestion plants. So from this side, there are opportunities. This can also be, of course, translated into any other countries of the world. What we now have to strive for is the abolition of the maximum rated output. There's a capping of production capacity, which is nonsense. We need more flexibility in the substrate use, and of course, and this is important, less bureaucratic hurdles and faster decisions on permits and access to the gas grid. Okay, now maybe a few words about technology, as we are technology focused today. So when we have a raw biogas, we have to upgrade it to biomethane. So basically we have to adapt it that it's suitable for the grid, and we have to increase the methane content so that it resembles actually the methane content of natural gas. So we have to dry the gas, the raw gas, we have to remove the CO2, carbon dioxide, but this can be used, and especially the industry is at the moment looking into the sources of biogenic CO2. They are scarce, but biogas can do it. And we need to desulfurize it, and also we need to odorize the gas for security reasons. So there are some or several technologies in the market how to actually upgrade the raw biogas to biomethane. And as you can see here, the main technology in Europe used is membrane separation. Interesting is maybe this is actually growing since 2010, because before it was not able to have long operation times for membranes, but this is now being solved. Very interesting, very new, cryogenic separation, which has several advantages, because by cryogenic separation you can very easily separate the gases depending on their melting point. And on the other hand, it needs a lot of energy, but yeah, it's always a balance about on which technology is then suitable for a particular project. Besides biomethane, we also have the opportunity to create synthetic biomethane for these matters. What we do is here we use the CO2, which we have to remove for biomethane from the raw gas. And with other energy carriers, solar and wind, for example, we can establish an electrolysis system. We can produce hydrogen, which we then, for example, can also use for synthetic methanation. So with that, we are actually able to double the output of biomethane in Germany, for example. But we also have the opportunity to use hydrogen in any other ways as storage material or in fuel cells or whatever is needed for producing heat, of course. Also there, biomethane and biogas plays a crucial role for the so-called biogenic hydrogen, which we still have to promote during Europe and especially in Germany, because it's not biogenic hydrogen is not yet really recognized in the overall strategies. But we think it's very important because we can also decentralize here actually the hydrogen production and usage. So how is biomethane used in Germany? As you can see here, the green curve, it shows you that, of course, the main part is still going into electricity, but this is changing now. As you can see here, for example, in the yellow curve, since 2018, there's a steep rise in the use of biomethane as a fuel. And this is owing to the fact that we have some dedicated regulatory tools. And so the legal framework in Europe bases on the so-called Fit for 55 packet. And the target is to reduce the GHG emissions by 55% until 2030. And there are several packages, sub-packages in this Fit for 55 packet. For us, the main Bible, let's say, is the so-called RED II, the Renewable Energy Directive, and there are also other directives which are covering topics like land use, for example, and like trading, cross-border trading, which is practically not really yet existent in Germany, and we have several regulations which deal then with the build-up of infrastructures. Especially here, the European Commission actually acknowledged that biomethane plays a crucial role in especially heavy-duty transport, and the member states are actually obliged to build up an appropriate number of LNG and CNG fueling points. So LNG is liquefied biomethane, CNG is compressed biomethane. And so this is a thing that we actually have to adopt until 2025. This is going to be difficult because we have other regulations which are in contrast to that. So that is what we are striving for. And here is to show you, for example, how GHG emissions are being calculated and audited and assessed. Because we have a fossil comparator, at the moment it's 94 grams CO2 equivalents per megajoule. And what is happening now with biomethane is that actually every production step, let's say, get its own CO2 backpack, as we call it in Germany. And as you can see here, cultivation, for example, is 0, but for the processing, you have a positive GHG footprint and so on and so on. But interestingly, for manure, you have a negative one, quite high negative. This is owing to the fact that if we use manure in a digester, we avoid the emissions that would actually emerge if we just dump it onto the soils. So this is a thing that the European Commission recognized, that there are also opportunities not only to go to 0 GHG emission, but even below. So operator and business model concepts from that side, especially from the fuel side, would be at first you have a biogas plant and you sell your raw biogas, for example, that's possible. But on the other hand, you are completely dependent then from the market participants, basically, so you have no influence basically on your business. The next step is you feed it to the gas grid, so you have to prepare it, as I explained before, raw biogas to biomethane, and then you can enter into a purchase agreement with a dealer or with gas station operator. And interesting is, so if, for example, you have a biogas plant, let's say in northern Germany, you have a takeoff agreement with somebody in southern Germany. So you put in the gas in the gas grid in northern Germany, and in South Germany it's being extracted again. But because of the deal and because of the assessment of the greenhouse gas emissions, it's balanced as, let's say, 100% climate neutral or even negative, even if actually in the grid the content of real biomethane is at the moment 2 or 3%. So this, of course, needs to be heightened, and we can in short time actually bring it up to 40% in the grid. A new trend in Germany is that biogas plants join together, and they would operate then an internal line, let's say, and would then supply the gas to a central biomethanation plant. So this is very interesting, especially for smaller plants to connect each other and then jointly operating, upgrading plants and also maybe fueling stations. So how is biomethane actually used in transport? So we have the bio-CNG, which is compressed. We have the bio-LNG, which is liquefied biomethane. And there is an obstacle that actually from 2035 all internal combustion engines should be stopped, but we are strongly opposing that, especially as I have explained before. Actually, we should by 2025, we should have fueling stations in place, but 10 years later, the internal combustion engine should be obsolete. So that doesn't make sense. And we are pretty sure that we can actually convince the politicians to say, okay, we are not stopping the internal combustion engines. What we are stopping are the fossil fuels. So this is actually important to distinguish. What I would like to finally introduce to you is our Divi matchmaking platform. The website is divico.org. This is funded also by the German government and by other institutions. And here you can actually explore and search for business opportunities in the fields of biogas, but biomethane, but also gasification. You can search companies, you can search suppliers, investors, project developers, and so on, and can interconnect with each other. It's an open platform, no costs whatsoever. You can directly enter, play around, and put in your data if you like. And then getting into contact with each other. So this platform is working worldwide. So we have target regions in Africa, in West Africa, and in East Africa, but also over the whole Latin America. I think I'm running out of time, so yeah.
Yes, thank you.
Maybe stop here for the moment.
Yes.
I gave you a short introduction about what the Biogas Association can do, and of course we are looking for collaborations. But I have also to make one mention, because what I experienced also from the connections, very valuable connections from last week. So we are not really entering into direct projects. So we are more facilitators, we are advocates, we can help with knowledge, and we are usually working, on a governmental to governmental side. So if there's, for example, a local biogas association or a local workers association, or whatever, then we can start to interact and interchange, but we cannot promote single projects. So thanks a lot for your time.
Dirk,
I would like to ask you, do you have presence in India as well?
Sorry?
Do you have presence in India also?
We are very strongly collaborating with the Indian Biogas Association. And interestingly, just before I had a talk again also with Gaurav from the Indian Biogas Association. I will also do a presentation there in a few weeks. So we are very active in India, and also looking into the knowledge transfer, so that we help in India to establish biogas plants and biomethane.
How do we separate CO2 from other gases?
Well, these are several technologies which I showed you here. So there are several opportunities of membrane separation, which is at the moment in Germany the best. We have water scrubbing, chemical absorption. So we have several opportunities to remove the CO2. And so this always is also an individual decision. Which kind of technology do I use? It depends a bit on the circumstances. Do I need to have a heat management, or don't I want a heat management, and so on and so on. And so there are several questions then individually to be solved, what technology we use to separate the CO2.
There is some membrane thickness for separating the different gases?
Yes, there are usually there are several layers of membranes, and every layer then separates a special gas, let's say. Yeah. So this is how the membrane technology works. As I said, 10 years ago, the membranes were not good. So there had to be a lot of research and development to finally make it working, which is now the case that it's actually the most common used technology.
Okay, thank you so much.
Thank you very much, Dirk. Thank you very much, Arno, for your questions. So, my dear friends, just a quick reminder: if you have some questions or some comments, you can use our public chat. Also, to leave your contacts there and to make all the comments. So, Dirk, now I will take away your presentators rights again.
All right.
Yes, And Thomas Schied, Mr. Schied, do you hear us? Thomas. Thomas. Thomas Schied. Thomas.
At least his screen is on.
Yes. His screen is on my screen, but I see here that he is wieder entsperrt, so it means everything should be good. Thomas. Okay, then, and Thomas Damani.
Yes, can you hear me?
Yes. Where is speaking? Who is speaking?
Damani, Thomas.
Thomas, because of the fact that Thomas Schied doesn't answer us because...
Hello, can you hear me?
Yes, Thomas Schied?
Yeah.
Okay, Thomas, please.
Yeah.
We are waiting for your interesting presentation. Please, you can see it on my screen.
Yeah. Thank you very much. Unfortunately, the camera is still not working, but I hope you can hear me at least.
Yes.
Yeah. Okay.
Yeah.
Good. I should have been the first presenter because I wanted to give you a brief classification of renewable and decarbonized gases in the context of the overall topic of the energy transition and the global challenges we are facing. So welcome to everybody as well from my side. I'm happy to be invited by Igor and to speak to you today. Yeah, please, the next slide, Igor. Good. Yeah, as we all know, it's more or less already 5 minutes past 12 if we use the metaphor of a clock when it comes to our aim to decarbonize our societies and the world. And we know that this is our tackling two of the major UN sustainability goals. To reach our goal in Germany, it's 2045. Other countries have 2050, or the Paris Agreement is saying. So we really need to make use of all the measures we have. So this is including what we speak today, the renewable gases, but we have to use as well all kinds of renewable energy technologies to produce electricity and other energy. We have definitely to look at all three sectors. So it's not about electricity only. It's about the heating market, where gas comes into play as well. And it's the mobility market, and all of them are interlinked. So that means we need to use all kind of measures regarding digitalization. So energy management tools to really reduce what we all use as electricity. So we have to make sure that we are energy efficient, that we don't use too much of energy at all. So meaning as well in the residential areas that we have to make sure that the usage of heating and electricity gets reduced, and all together needs to be interlinked, and as a whole might hopefully still make us reach the goal we are all aiming for. So as I said, next slide please. We are using as well or need to use as well the renewable gases. It's a little bit difficult to read out as I see, but I just have taken this from the internet anyways, because I wanted to give my kind of definition, or what I think is the best definition for renewable gases. And this is any gas which is produced from renewable energy resources, in my perspective. So that means the renewable energy resources like wind, solar, geothermal, but as well as we heard biomass, landfill gas, sewage treatment plant gas, and biogas. All these kind of energy are under this umbrella. We've learned already how it gets produced and technologies, and we have to focus on the last point of this slide, the issue, because it's a very important part for it. It's part of the game-changing play, because if we use renewable energy, we're not in a position to balance demand and supply very well. It means that we need storage as well, electricity from wind and so on. And how can we do this? The one way is to use the power to gas technologies and to make this as well a possibility for a kind of seasonal storage, and really to find a way to match supply and demand decently. And there we have as well the way of renewable gases, which are then part of this solution. The next slide, please. However, we have to avoid, as I name it, and you can hopefully see the picture from the carbon tunnel vision. There are many other challenges we are facing. It's not about only energy challenges, it's environmental challenges like water treatment, and that we are running out in different areas of real drinking water. We have economic challenges all around the world as well through the war now, and we have social challenges, and they are interlinked. So if we look at the emissions only, that's not enough, because resources and even use cases are as well somehow competing with each other. So we need a holistic view, and as Dirk before already said, in many areas of the world as well, for making biogas or renewable gases, you even plant corn and use corn to afterwards produce biofuel, biogas, and whatsoever. But in this way, I think it's not a good example to do so, because if we lose land for that instead of using it for agriculture, since we have as well to produce sufficient food for an increasing number of people on Earth, we have really to make a choice which is the best use. And there we come to the next slide of my presentation. I think we need to, I just use the metaphor, the picture of a merit order as we have it in electricity, where you say the power plant, which is at the lowest cost, is producing first, so to speak. And I have transferred this idea to say we need a merit order of, let's say, renewable energy sources and technologies. And it's looking on the use case, on a certain use case, and looking at total costs. And then we have to decide where we want to use which, or where we can best use a certain solution. And for the decarbonized renewable gases, which are the best use cases, is a question. And it's not about only the energetic, but also about material applications, because there is an input we need for the chemical industry, for instance. And if we take all these, I mean, you have to shorten this, it's a difficult topic. But if we look at this, and we have to look at this in certain areas of the world, it might be differently. So there are local requirements and certain KPIs which need to be fulfilled, because at the end this must be as well economic feasible for companies, otherwise you won't do it. So we have to create this kind of merit order for different areas in the world, and the potential outcome, so to speak, could be that we use electricity or battery electricity for individual transportation, that we might use hydrogen for the heavy trucks and aviation, that we definitely have to make more use of waste heat for local heating supply. And in other areas, like maybe in Africa, you could potentially focus on PV with a district storage, and then you build a local DC grid instead of AC grids like we have in Germany, which might be much more sufficient than if you use, for instance, PV. And that's how I mean we have to develop this kind of best in class use cases, and energy from biomass at locations where it is where we have required supply locally, and where the input is available on site is maybe the best way to use biomass. So to give you some key takeaways, I would say, next slide, please, which are, let's say, an outcome of this presentation, which is really in our run through in very quick time. I think it is best to use directly renewable energy or electricity if you can directly use it, yeah, because if you transfer it to hydrogen or whatsoever, you just lose a lot of the energy due to efficiency issues. You need to use renewable and decarbonized gases as an integral part of the energy transition. We won't do it without, and I personally believe that hydrogen might have the largest share in it. The biofuel producers definitely might become suppliers to the chemical industry, as I said, because if we decarbonize, we have as well in the chemical industry to make need other input factors than the fuel used today. So other input factors than natural gas and oil for giving the production of the chemistry a good future. Without CCS, so carbon capture storage, and the active removal of CO2 from the atmosphere, I'm pretty sure that we won't reach our goals at the very end. And now comes two very important issues where we have to focus because technology very often exists, but we need to work on the legal and regulatory framework to be appropriate that we can use renewable gases in the best way, for instance, and we might need new and sustainable business models which are required. And this would be a focus area where I'm working on and where I could potentially support you or anyone who has a project at hand to work on this kind of business models to scale up technologies which support our climate goals. Yeah, that's it in very brief. Thank you very much for your attention, and happy to answer your questions and to connect on LinkedIn any day.
Yeah,
Thank you very
Mr.
much.
Thomas, may I ask you one thing? How much is the percentage of hydrogen?
Well, currently the percentage is rather low, at least in Germany, Europe. It's an upcoming industry, if you want. So while we have, I mean, hydrogen is used for a long time in the industry, and in the industry the amount might be quite high, but we speak about green hydrogen. That's what we need, because otherwise we are not on the pathway of CO2 free. Nowadays, hydrogen is very often made out of natural gas, so it's not CO2 free in the industry sector. But if we want to roll it out and if we want to use it in different areas and as well in maybe even in the heating areas, then we definitely need renewable hydrogen, and there we are at the beginning. But I think that we can go up until 20% of the total energy usage. But still to be answered, the business models are not existing, and even the infrastructure is for the time being not sufficiently existing.
Thank you.
Thank you very much. Thank you very much, Thomas. I have questions, but I think we will discuss it if we have just a little bit more time. And now I would like to introduce our colleague from Jamaica, Mr. Thomas Damani. Thomas, you are here. Can you see and hear us? I will show your presentations now. Just a moment.
Yes, I can hear you. Can you hear me
Oh,
clearly?
very good, very good, very good. This is your presentation, I think, yes?
Yes, I believe so.
Yes, Mr. Damani, please say several words about yourself, introduce yourself shortly, and then to your presentation. Thank you.
All right, so thank you, Igor. So hello everyone. I'm Damani Thomas from Jamaica, as stated. I am the founder and CEO of the Carbon Neutral Initiative, and I will get into what the Carbon Neutral Initiative is right now. So The Carbon Neutral Initiative is a Jamaica-born company found to tackle global environmental issues and help other countries reach their SDG goals, as previously mentioned by the other Thomas. Now, we reach those goals through creating climate resilient technologies. What we do is that we mainly fall into the field of decarbonizing transport, where we create technologies such as specialized carbon capture and biofuels. Now, we aim to decarbonize from both ways by using drop-in technologies. Now, as for the specialized carbon capture project, that is called the carbon attack filter, and that's a biodegradable carbon capture filter designed to trap emissions from passenger cars. So this is our energy project, and I will get into it right now. Next slide, please. Now, this project is called the D30 Biofuel, and it is a fuel that was created to be more sustainable than ethane. The slides. Yes. So this solution was created to be more sustainable than ethane, being that it is more compatible with other vehicles because it does not possess the same corrosive properties as ethanol. So this fuel is also made using the same bioethanol feedstock, as such make full use of the existing infrastructure and the availability of ethanol. Next slide. So the problems we faced as to why I created this solution is that most government refineries operate at a loss and private refineries operate at low profits. Now, I believe that we can create a solution that decarbonizes transport right now. Now, this solution was created as a drop-in solution, while the electric market, the EV take over the market. So we still have about 1.3 billion passenger cars out there right now that is internal combustion. So we need a fuel that has a higher environmental impact. As such, we created the D30 fuel. Now, the D30 fuel is there to be a replacement to ethane, and ethane is one of the most used biofuels out there. Now, there are a lot of problems with ethane, such as that it has a low energy output when compared to raw petrol, and that also causes you to get a bad fuel economy. It reduces fuel economy by 3% because it have lighter fuels, and it also have a small carbon reduction impact for being around for so long. Now, it has a carbon impact of about 5 to 7% less, in which I believe that we could do better than that as we are right now. And again, it's not compatible with many vehicles. Now, there are about 10% of vehicles in the UK and even more around Europe that cannot use ethane because the corrosive nature of ethanol combustion. Now, the D30 fuel is a semi-synthetic fuel designed to be more sustainable than ethane. Now, the D30 has a higher energy output and uses more complex synthetic biofuels and less petrol, resulting in a more environmentally friendly and cost-effective transportation fuel that burns cleaner but is cheaper than its predecessor. Next slide. Now, these are the impacts of the D30 biofuel. As you can see, as for our environmental impact, the D30 fuel reduces greenhouse emissions by a minimum of 10 to 15% when compared to ethane that reduces by 5 to 7. As for economic impact, now energy budgets can be lowered because we use a strategy that step away from fossil fuels. So in the same way that E10 helps other countries reduce their fossil fuel intake, the D30 fuel uses a similar strategy but scaled up by magnitudes. As for social impact, as stated, the D fuel is more energy dense. So the D30 fuel is not only cheaper to produce, but is also cheaper in the long run for drivers because they have a more energy dense fuel that does not affect their fuel economy negatively. So they get more value per liter. As such, it requires less refueling. Next slide. Click again, I guess. Yes, so that brings us to our SDGs. Most notably, affordable and clean energy. I mean that we created a fuel that is cleaner than what is being currently used. Also decent and economic growth, industry innovation and infrastructure, and of course, climate action. So our next slide. Now, our business model in bringing this solution to the market is that we chose to go with a license and revenue model so where we can license this solution to a number of other refineries that we can help them decarbonize their operations. Now, what we aim to do is that we provide the oil refineries with the solution in the form of a formula, and it is then implemented by them, and we generate revenue through a license and revenue model. Now, we chose to go with this model because it would be the most sustainable, being that the other option would be to make our own refinery, which I think that would be very environmentally counterproductive. So what we aim to do is to help these bigger companies decarbonize their operations. And another great thing about this fuel is that any refinery that can produce E10 can produce D30. So there is no need for new infrastructure. Next slide. Now, this is our most recent of discoveries in research. We know that after a while, the petrol fuel will become more and more obsolete as the EV markets takes over, and their use of more renewable energy like solar and so on. Now we are looking into decarbonizing the transport industry by using the D30 formula. We hypothesize that we can create a bioaviation fuel through the alcohol to jet process using the same ethanol feedstock, but having a low oligomerization cost. And it creates its own aromatics as opposed to the current process that you would have to add the aromatics to synthetic bioaviation fuel. So next slide. So as stated, the strategy of creating biojet fuel that we will be using is the ethanol to jet. So the most notable difference between our process and other process is that by using the ethene by itself, it has a very high oligomerization cost because there is a lot more recycling, and this causes a lot more. On to the next slide, please. Now, what we aim to do is that we improve the ethanol to jet process by also increasing the variability. That means that we increase the length and branching qualities of the alcohols before they are entered into the oligomerization process. So that way it creates a lot of more dense fuels and create more biokerosene faster. And this research has been going very well. It shows a lot of promise, and we will also be looking to get more into the decarbonizing of the aviation industry. I think that's it for our presentation.
Thank you very much, Thomas. Thomas, I have a short question. Have you tried this technology in practice? And if not, when do you plan to do it? So you are probably looking for partnerships in this area. Am
Yes,
I
sir.
right?
Yes, sir. So as for the D30 fuel, petrol fuel, we have done a number of tests. We have did about 3 generations of improved formularization, and we did 2 tests, two different phases of testing during those 2 improvements. As for the bioaviation fuel, that is still in the research phase. I think we still need techno-economic analysis and a life cycle analysis also.
Okay.
And I think getting the answers to those two processes will be all the research that we need.
Okay, thank you very much. Okay, we will think it over and we will discuss this topic next week on our working group meeting. Come and we will, I have ideas. Okay, thank you very much. And now I would like to invite our, just a moment, our distinguished Georgi Peyev. Mr. Peyev, moment.
Yes, thank you, Igor.
Yes, just a moment. Just a moment, Georgi. Yes, Georgi. Now I will show your presentation. Yes.
Okay.
Now.
Few slides.
Yes.
Of course. Thank you, Igor, and thank you for inviting me here today to be part of EU Tech as well. And let me introduce our company. ICB Interconsult is developed by 2 Bulgarians originally who took over from a bankrupted Danish company back in Scandinavia approximately 26 years ago. And since then, they have been developing over 350 projects altogether for the time being. You can get to the next slide, please, if you wish. Yeah, and we are a group of approximately 165 employees. Most of them, of course, are software engineers. We have 3 main pillars. The first one is digital transformation, as you can see, and second, industrial Internet of Things, and the third one is simulation and virtual reality. We are distinguished partners of Microsoft partner, and we work together with Software AG in Germany, which is the second biggest software company after SAP. And as you can see on this slide, we have received a few awards as well too from Deloitte and different other occasions. Next slide, please, Igor. Yes, and then we can go to the projects. Below you see actually a project which is done together with the Volkswagen Group for the quality reasons of the paint which has been put on the vehicles itself, together with Konica Minolta, of course, and What's that company? Next slide. Yeah, this is one of our projects we have been able to develop together with Kongsberg Maritime and Kongsberg Digital. This is the company who took over ICB Interconsult last month. They have bought over a stake of 65%. And this is actually this project which you see on screen right now is together with T2. It's actually very popular quite right now because it saves a lot of energy in all of the ships. Kongsberg operates roughly about 950 ships altogether, and you can imagine that they are able to extract data between 10 and 40,000 parameters per second per ship. Next slide. This is what it brings again for the vessel visual inspection, which gives the possibility to be more energy efficient, to reduce the oil consumption of the ships. Next slide. I've been able to develop also projects in the health sector, as you can see, and we're doing that with the help of HoloLens2 Microsoft glasses. Next slide. This is another picture, which is giving you a chance to browse to a real operation. One of them is also done in Berlin, where Derek they were in hospital, the Red Cross. But yeah, I will end this slides as Igor said, and then I will be happy to share with you some information from McKinsey, which I've been able to extract, as we have been in contact with them recently about the green corridors, a lane of for zero carbon shipping. Zero emission fuels and vessels will need to start being deployed at the scale of the next decade to achieve full decarbonization of the shipping sector, which we are very deep in right now. And this has to be done by 2050. And its ambitious goal could be catalyzed by the green corridors, which have to be used in the shipping sector. This is the lifeblood of global trade accounting. Approximately 80% of all trade with further growth expected. The sector also represents about 3% of the total CO2 emissions, and amount that if unchecked could rise by as much as half by 2050. Recognizing the need for climate action, the International Maritime Organization has mandated emission reductions of 50% for all vessels by 2050. And a number of countries, including Japan, UK, and States, have declared the target for net zero shipping emissions in the same time frame. To reach these goals, because ships have 20 up to 25-year operating life, the sector will need to implement a comprehensive zero emissions program over the next decade. Necessary technologies are available, but they need to be deployed, and not only greater scale and speed, but also at lower cost. The zero emission fuels will cost significantly more than conventional fuels right now, raising the total cost of the vessel ownership between 40 to 60%, depending on the route. Finding industry-wide solutions is challenging, of course. Gives the wide and complex nature of the sector. One way to accelerate decarbonization is to implement green corridors for ships, specific trade routes between major port hubs, where zero emission solutions are supported. A new report, which was prepared by Next Wave Green Corridors, has been produced to get into zero carbon in collaboration with the Global Maritime Forum, Mission Possible Partnership, and Energy Transitions Commission, with analytical support from McKinsey, that probes the visibility of doing such selective orders with encouraging results. Furthermore, as you can see, this was an extract of our distinguished partner. That's what Igor shows right now on screen is Upkeep, our Industry 4.0 software platform, which we developed together with one of our colleagues who is our most valuable partner of Microsoft. He was able to write a chapter book for Bill Gates as well too, for the artificial intelligence sector. Next slide, please, here. This is our factory. This is HTS Dynamics, the factory which actually is operating with our software platform. They have roughly about 55 CNC machines mostly. And last slide, please. And now, which I want to stress for, these are the CO2 emissions and power consumptions. We've been able to extract data real time and also historical data in order to reduce gases. That's briefly from my side for today. And if you wish, we can get in touch and evaluate on that. Thanks, Igor, again for having me.
Yeah, Georgi, thank you very much. I have a short question. It's well known that power consumption plays an important role in the common program of energy restructuring. Yes?
Yes, correct.
Not only using of renewables, but only consumption. And
yes.
How do you think what percentage savings could give such technologies you spoke about, and in what economic sectors? So we understood it so that it can be used in all the economic sectors.
That's correct.
All the enterprises, yes?
Yes, that's right.
How do you think? How do you see this situation with consumption? I think that it could be it could give a percentage savings of 10-15%.
Yes, that's what we have been measuring actually, and what we have been previously discussing with you. It gives between 10 and 50% in real time and in real life, and the factories where we have developed our software platform and where we're using our software platform called Upkeep. So that's in Norway where we're doing that, and also 2 more factories in Bulgaria. There's one for machine tooling production, and the second one for production of bottle caps. So you can imagine what kind of energy consumption it is. So you have to produce, say, 5,000 bottle caps for 1 minute for 60 seconds. So it's really getting inside. Nowadays, as electricity prices are jumping tremendously, it's very important to try and reduce energy consumption, as you said. Thank you for your input, for your question.
Yes, thank you very much, Georgi. So I would like to ask Dirk. Dirk, are you here?
Yes, I'm here.
Dirk, I have a question after your excellent presentation. So as you know, we are cooperating with African partners and with partners in Asia. A number of technological and organizational solutions of the biogas sector in Germany and in the EU countries can be implemented in developing countries in Africa and Asia. I think it is so. Taking into account adaptation to the specifics of agriculture in them, natural and climatic conditions, what could be difficult in this kind of implementation? Because we are holding working groups on regular basis with African and Asian partners. and and very many people come from Africa and they want to cooperate on this field. Yes. How do you see this perspective on your professional point of view? Thank you, dear.
Well, especially for emerging countries, biogas is an absolutely brilliant solution because apparently or obviously emerging countries are very much dependent, and the society and also the economics are based on agriculture. And of course, we also have to decarbonize agriculture, but the good thing is that biogas predominantly is being produced from residues, from biogenic waste from agriculture. So we had it before. I also said, we do not need corn or anything like that in biogas plants. In fact, in Germany, we have also strict regulations for that. But for example, all the reminders of corn, the leaves, for example, cheese, whatever, they can actually be used in biogas plants. And we are doing, together with the German GIZ, the Society for International Collaboration, we are doing trainings in Asia, particularly, for example, in the Philippines. We helped in Rwanda to build up also biogas association. We have projects in Ghana. And the important thing is to provide knowledge how to operate a biogas plant, because what we have seen is, especially for example in Mexico and Latin America, in Mexico there are so many biogas plants, mostly, by the way, based on German technology, because I have to brag here. I mean, the Germans do deliver the best biogas technologies, and practically it was invented in Germany. But there is a lack of properly operating biogas plants, especially the gensets, the CHP units. And this is something that needs to be trained, because it does not make sense, of course, if you install a biogas plant, but then it's emitting, for example, more methane as it's actually taking in. This can happen. And there are no actually trained people to operate or to maintain the gensets. So these are maybe the obstacles. From the technology side, I think it's no problem. Biogas and biomethane can be used as a joker in renewable energies, and so especially for emerging countries, it's a good opportunity. And there are also small installations of biogas plants which are easier to operate. So there are a lot of opportunities also to diversify local economies, because on the other hand, you also have the digestate. So once the bacteria did their job, let's say you have to do something with the leftovers, and they are perfectly fit for fertilizers, because you also can actually then omit, and you do not need mineral fertilizers, which are scarce and expensive.
Yeah. Yes, we are creating a new alliance, agriculture alliance now. And some German colleagues who will be very active in this alliance, they have already addressed me with a question how to make contact with you to discuss these practical aspects of biogas in the agriculture. Yes. Mm-hmm. But we will discuss it. Thank you very much, Dirk.
Thank you.
Yes, thank you. Mr. Thomas Schied, are you here?
Yes, I'm here.
I don't know if our distinguished attendants have questions, because I have a question for you. And it will be the last question, and after that, we will, so our colleague Benedikt Grütz from European Senate will take a word, but I have a last question. In recent years, there has been a promising development of the use of hydrogen as one of the main gas renewable energy resources, which is able to provide up to 20% of the required reduction of global CO2 emissions. Yes? What do you think about it, and what do you think about green hydrogen? Is it really so that if we will be able to get this green hydrogen, we have very good future. So how do you think about
Well, that's what we wish for. I mean, the green hydrogen definitely has big advantages. Also, as I said, it's much more efficient if you can use the renewable electricity directly. But for reasons like as already today, I mean, production and where the supply and demand is not on the same location. And we in Europe, we will have difficulties, at least from the current point of view, to produce sufficient energy ourselves. And yeah, with the green hydrogen produced in other areas of the world, I mean, it's comparable maybe to today LNG, which you transport as well with ships. There seems to be a good future for it. Still, the costs are very high, and the infrastructure needs to be built and to be invested into. But I see no chance to reach our goals at the moment without making use of hydrogen. So that's my perception. A lot of projects are going on, and a lot of money from the European Commission, but as well from the German state, is going into hydrogen business. And I hope that we will have a breakthrough for this kind of technology. And as I said, for the global challenges, it does as well help for the social challenges, if you want so, because it offers income to countries outside Europe, which can be producers of this green hydrogen.
Thank you very much, Thomas. I would like to introduce my colleague Benedikt Grütz. Benedikt, are you here?
Yes, I'm here, Igor. Thank you very much for having me. And I have to apologize, I have no webcam today. So Thomas and me, we are doomed in the same way. So, but nevertheless, I'm here and I'm Benedikt Grütz, and I'm Vice President of the European Senate of Economy and Technology. And on behalf of EUTech and the Senate, I'm happy to present a little gift for our panelists. Now I will start my screen sharing. Just give me 1 second. Well, as you know, or you maybe know, the climate protection is not only one of the biggest goals of the United Nations, but also of us and our organization. And therefore, we are very active with our own climate action partnership. And here we go. Here are the tree certificates. Here with the European Technology Chamber confirms that a tree for Thomas Damani, a tree for Georgi, a tree for Dirk, and last but not least, a tree for Thomas Schied has been planted in Africa by our EUTech Climate Action Partnership. So thank you very, very much for this great panel. I think there were a lot of good points to discuss about further. We are very much appreciated, and thank you very much for being our guest today. And so, ladies and gentlemen, that was my short part today without webcam. Sorry again for that. Again, thank you very much, dear guest. Thank you very much, dear panelist. And I think for the last words, back to you, Igor. Thanks for listening.
Benedikt, thank you very much again. And you will send these beautiful certificates to our panelists, yes?
Surely I will.
Okay. Very good. Thank you very much. It's our practical cooperation with partners in Africa. And so we told about it. So our time isn't not enough to discuss all the topics, but I hope that we will further be able to discuss it on our working group meetings, for example, next week, because I already have many questions, many requests from other people who were attending our webinar. And I will provide all the questions to our distinguished speakers, and I will be very, very glad if we have new contacts, new business possibilities. And on behalf of European Technology Chamber, I am telling you, thank you very much for attending of today's webinar, and see you next time. Thank you.
Thank you so much.
Thank you. Bye-bye.
Thank you, Igor.
Bye.
Bye bye.